Good morning all. Welcome back to Chemistry Laboratory, Kebri Dehar University, Somali region, Ethiopia. This is Dr. Rajshekar Medidi, Chemistry Department. Today we'll discuss about the new experiment, that is analysis of mixture containing sodium carbonate and sodium bicarbonate. So here the aim is estimation of the mixture sodium carbonate and sodium bicarbonate in a given mixture unknown solution. Apparatus will be the same like the previous experiments: burette stand, pipette, volumetric flask, conical flask, beakers, spatula, weighing machine, wash bottle, etc. Coming to the chemicals required, we need to have the different types of chemicals are there here, that is sodium carbonate, sodium bicarbonate, hydrochloric acid, and borax is also there. So coming to the indicators used here, because it is a mixture, we need to use the two different types of indicators. The first indicator is phenolphthalein and second one is methyl orange indicator. So phenolphthalein indicator, coming to the end point now, phenolphthalein indicator produces the color change from pink to colorless. Now coming to the reaction mechanism here, the mixture solution containing sodium carbonate and sodium bicarbonate present in the conical flask is titrated with the hydrochloric acid from the burette. First of all, we need to add phenolphthalein indicator 2 drops. When we add the phenolphthalein indicator into the conical flask, because it is in basic medium, it exhibits pink color. Slowly burette is released by adding HCl from the burette and titration is continued, and at a particular point this pink color will be converts into colorless. That is first phase reaction. In this first phase reaction, what happens is the sodium carbonate present inside the mixture will be transfers to sodium bicarbonate. Therefore, the color changes from pink to colorless. And now when we add the methyl orange indicator, immediately when it gets colorless solution, it appears yellow color, because methyl orange will be exhibiting yellow color in basic medium. Still sodium bicarbonate is there in the conical flask. Again the titration is continued by adding HCl from the burette. Now what happens is, when all the sodium bicarbonate present inside the conical flask will be completely neutralized to sodium chloride salt. Therefore, yellow color will be converting into pink color finally, and therefore the reaction ends. So this is the mixture analysis reaction. Very interesting experiment, very thrilling experiment to see the color changes by using two different indicators. So this is belongs to the acid base titration. So let us perform the experimentation visually, practically. Now let us perform the experiment here. Let us perform the experiment. This is the conical flask containing the stator. So this is the borax for the part 1. Standardization of hydrochloric acid by using standard solution of borax, part 1. Now I will take 10 ml of borax. This is 10 ml. Borax is added into the conical flask. Right. Now 30 ml of distilled water. This is 25 ml of measuring cylinder. This is 25, and simply approximately 5 ml. 30 ml distilled water I added. Now I am operating the stirrer. Now I have to, these are the two indicators, methyl orange indicator and phenolphthalein indicator. Now this is the part 1. We have to estimate the strength of hydrochloric acid by using borax. So we are using methyl orange indicator for part 1. Now I will add 2 drops of methyl orange indicator. It is yellow color. Now this is the burette. containing hydrochloric acid, where the strength is not known. We find out the strength here. Now this is up to the mark 0, 50 ml burette. I am titrating. See the color change. This is yellow color when I added the indicator, methyl orange indicator. Now we are performing titration with HCl. I am slowly adding. It changes into pink color. That is antibody. Carefully observe the color change. Yellow is slowly converting into pink. Suddenly it changes. Yes. See the color change? This is pink color. Yellow color changes to pink color. Now, note down the value. This is 17.7. See, 17.567. This is the titer value, 17.7. Note down the titer value. Then we will go for the part 2 to analyze the mixture containing sodium carbonate and sodium bicarbonate. Yes. Now we will perform the experiment for part 2 for the estimation of the mixture containing sodium carbonate and sodium bicarbonate. Let us perform. This is a clean conical flask with stirrer, and now I will take the mixture. This is the sodium carbonate and sodium bicarbonate mixture. We have to analyze. We have to analyze how many grams of sodium carbonate is there and how many grams of sodium bicarbonate is there. We have to analyze from this mixture. So I am taking this one into the small beaker for the convenience. This is the mixture. Now this is already washed. Pipette is already washed. Now I will take 10 ml of the mixture. This is 10 ml. Yes. Now I will add 30 ml of distilled water as usually to increase the volume for the color change clarity. This is 25 ml and another 5 ml. Yes. Now I will on the stirrer, magnetic stirrer. Add the indicator. First one, phenolphthalein indicator to be added. Phenolphthalein indicator, 2 drops may be added. Yes. We have seen the color change. See the color change. We got the pink color appear. Now we will titrate with the hydrochloric acid from the burette, where the strength is already known. So I am making it up to the mark, 0 mark. Yes. So from part 1 we got the strength of hydrochloric acid as 8. The titer value is 18.2, and the normality of this hydrochloric acid from part 1 is we got 0.0549. Now we are performing the titration with this HCl with the mixture to identify to estimate the amount of sodium carbonate and sodium bicarbonate. Let us see the color change. Pink color converts into colorless. Yes, we can see. Yes, now it is completely color change. See, the color becomes colorless. This is the first phase reaction is completed. The value is 1. The value is 1.8. 1.8. And now I will add the methyl orange indicator immediately. Now I will continue the iteration. So here from 18.2 I am continuing. So when we add the methyl orange, the color changes to yellow color, from colorless to yellow color. Now this color will be converting into pale pink at the end point, where all the bicarbonates converted into salt, sodium chloride. Yeah, see, this is the end point, completely converts into pale pink color. So now record the value, titer value, that is exactly 5 ml. 5 ml. Methyl orange endpoint is 5 ml. So phenolphthalein endpoint is 1.8. So this is about the reading. This is about the titration completion. Now let us perform the calculations and find out the amount of sodium hydroxide present in the given flask and also the amount of carbonate present inside the given flask. Now let us perform the calculations on the board. Now coming to the calculation part, that is for part 2. After part 2 we are going for the calculation, that is estimation of sodium carbonate and sodium bicarbonate mixture. So the procedure is part 1 will be standardization of hydrochloric acid with standard borax. So hydrochloric acid to be standardized with borax, which is already standard. So then from that we will get the strength of hydrochloric acid that can be used to determine the mixture of sodium carbonate and sodium bicarbonate in the given sample. Now the procedure is standardization of HCl procedure is, we can see 10 ml of borax is taken into the conical flask, 30 ml of water is added, 2 drops of methyl orange indicator is added, you will get the yellow color. Now titrate with HCl from the burette where the strength is not known, endpoint is pale pink color. Here are the readings what we got from the observation after experimentation. Table 1, volume of borax taken is 10 ml. Burette readings are initial final. The final volume we got is 17.7 ml. That is final. So law of equivalence formula N1V1 is equal to N2V2. N1V1 for borax and N2V2 for HCl. Now N1 is equal to normal to borax is 0.1 normal, that is standard, and volume of borax is taken 10 ml. And N2 normal of HCl taken is, we don't know, X, and volume of HCl V2 is equals to 17.7 ml. So from this we got the strength normal of HCl N2 is equals to N1 V1 by V2, that is equals to 0.1 into 10 by 17.7, that is normal of HCl in part 1 is 0.0564. So from this normality we'll find out the mixture, amount of mixture containing sodium carbonate, sodium bicarbonate. We'll find out the grams present in the mixture. So part 2 is estimation of sodium carbonate and sodium bicarbonate mixture in a given sample. Procedure is 10 ml of the mixture is taken, 30 ml of water is added, distilled water, and 2 drops of phenolphthalein indicator is added. So we'll get the pink color after adding phenolphthalein. Then note down the then we have to titrate with HCl, which is known strength of 0.0564 normal, and titrate with the HCl, we got the endpoint, that is colorless. Pink color changes to colorless, that is the first titer value for sodium carbonate endpoint. And again continue the titration with HCl from the burette by adding methyl orange indicator, will get yellow color. Now finally yellow color changes to pink color at the endpoint. This is the two-phase reaction. Now from table 2 we got the value. Volume of mixture is 10 ml and initially it is 0, and phenolphthalein endpoint for sodium carbonate estimation is 3.2 ml and final volume is 4.7 ml. So the second endpoint will be at 1.5, that is 4.7 minus 3.2 is equals to 1.5 ml. So phenolphthalein endpoint is 3.2 ml for sodium carbonate estimation, and methyl orange endpoint is 1.5 for sodium bicarbonate estimation. This is about the value squat. And again going for the formula, law of equivalence, N3V3 is equals to N4V4, that is sodium carbonate for N3V3 and N4V4 for HCl. Now this is the incorporation of the, just put the values. N3 is equal to normal of sodium carbonate is X, we don't know, and V3 is the volume of sodium carbonate is 10 ml, that is taken, and V4 is equal to normal of HCl is 0.05, that is we got here 0.0564 it is, and volume of HCl is 3.2 ml. So now let us see the calculation. N3 normality of sodium carbonate is equals to N4V4 by V3, that is 0.0564 normality of HCl into 3.2 by 10 is equal to 0.0180, that is normality of sodium carbonate. By getting the strength of sodium carbonate normality, then we can find out the amount present in the sample. Amount of sodium carbonate present in the 100 ml flask is equals to normality of sodium carbonate into equivalent weight of sodium carbonate by 10. That is 0.0180 into 53 by 10 is equals to 0.0956 gram of sodium carbonate present in 100 ml of the flask. This is about the calculation of the mixture containing sodium carbonate. Now we will find out the calculation for sodium bicarbonate in the same mixture. Now we are finding out the amount of sodium bicarbonate present in the given sample. We got the value 1.5 ml for methyl orange indicator endpoint, and the formula is N5V5 is equal to N6V6, that is N5V5 for sodium bicarbonate and N6V6 for HCl. If we take like that, and the calculation is N5 normality of sodium bicarbonate is not known, X V5 is equal to volume of sodium bicarbonate is 10 ml from the mixture, and N6 is equal to normality of HCl, that is 0.0564 from part 1, and V6 is equal to volume of HCl is 1.5 ml. So now as per the formula, N5 is equal to N6V6 by V5, that is 0.0564 into 1.5 by 10 is equal to 0.0084 normal sodium bicarbonate. So now amount of sodium bicarbonate present in the 100 ml flask is equal to formula normality of sodium bicarbonate into equivalent weight of sodium bicarbonate by 10, that is 0.0084 into 84 by 10 is equal to 0.0710 grams of sodium bicarbonate present in the given 100 ml of flask. This is about the calculation, estimation and the calculation amount of sodium carbonate and sodium bicarbonate present in the given sample. Thank you.